Hello, welcome to Parallel Perpendicular Lines lesson. So in this lesson, you will learn how to write equations for parallel and perpendicular lines. Also determine whether or not lines are parallel, perpendicular, or neither from 2 points and from 2 equations. So let's begin. Let's first talk about parallel lines, what qualities they have. And parallel lines never touch, so they have the same slope. So we would see, for example, y equals 2x plus 1 and y equals 2x minus 7. We see that they both have a slope of 2. All right, for the perpendicular, we know that we kind of use that symbol, that upside down T, as you recall from previous courses, but they have opposite reciprocal. And what that means is they are opposite signs, so one's positive, one's negative, and the reciprocal is it is flipped. So for example, y equals 3x minus 7, so 3, and then y equals negative 1/3 x minus 7. So these slopes, one's positive, one's negative, and then one is flipped. When we flip a whole number, we know whole numbers are over 1, so when we flip that, it becomes 1 over that number. So let's go ahead and take a look at some examples. If they determining if they're parallel perpendicular, don't have our 2 points, but basically it would be what we did in our previous lesson of finding the slopes of both and then comparing them. And so for down here, we have it in equation form. So we need to get them into slope-intercept form in order to determine if they are parallel. So we got to see their slopes. So for this first one, I'm going to go ahead and undo this, get it to the other side with subtraction. So it's going to be y equals negative 2x plus 3. And then this one, I'm going to add 2x to get it to the other side. So y equals positive 2x plus 7. So I see that I have a negative 2 and a positive 2. Well, they're opposites, but they're not opposite reciprocals, and they're not the same. So this would be neither. This one, remember our horizontal and vertical lines? Well, x is our vertical and y is our horizontal. So one being vertical, one being horizontal is going to be perpendicular. I'm sorry for my awful handwriting. My pen is the tip is starting to, I think, gonna break off here anytime. So bear with me, I might be getting a new pen soon. On this third one, we're going to get this to the other side by adding it. So it's y equals, if I add 5x, then I'm going to have a 5x plus 12. I like to put the slope for keep it in y equals mx plus b form. And then here, let's subtract our x. So y is going to equal negative x plus 7. So my slope for this one is 5, and my slope for this one's negative 1, so those are neither. And my lines got off here, so I might end up going on the second page. Okay, so for this one, what we want to do is we want to find our slope first, and we're going to both be writing a parallel and then a perpendicular, it looks like, I think for A and B. So we're going to start with parallel, but we need to find our slope. So I'm going to go ahead and subtract 5x, and I'm going to have 2y equals negative 5x plus 8, divide by 2. And y is equal to negative 5/2 x plus 4. But really the 5/2 x is the 5/2 is what I want. There we go. So if my slope, my m, is negative 5/2, then I want to use that same slope. So for A, parallel, then I'm going to be using point slope form, the point they give me, y minus, and here's my x1 and my y1, and I'm going to put my 3, make that a y, there we go, and equals my slope, parallel, so I keep the slope the same. So my m is going to be that, and then x minus, and my x1 is 5. So now I'm going to go ahead and distribute. And then here to multiply, remember we multiply the numerator times this number, so 25 halves. And I'm going to add 3. Now, when I add 3 to this, 3 is the same thing as how many halves? Well, 6 halves, because 6 divided by 2. So I'm going to add 6 halves to my 25 halves, which is the same thing as adding 3. And that is going to give me 31 halves. And you could do that in your calculator if you're scared of those fractions. You can take 25 divided by 2, enter, plus 3, enter, and then math, enter, enter to get it back to a fraction, which would be 31 halves. All right, so there's our parallel. I'm going to go ahead and write that one down here on my parallel line. And then we are going to figure out perpendicular. And I'm going to do it down below this little section here. All right, so perpendicular. Now I need to change my slope. So let's go ahead and change our slope to be opposite reciprocal. So if it was negative 5 halves, I'm going to put the 2 on top and the 5 on the bottom, and it's going to become positive. So now for B, perpendicular, it's an R. Okay, we're going to do y minus, and we're going to do the same point from up above, 5, 3. So I'll bring that down. So this is my x1, this is my y1 still. So the only thing that's changed is my slope. So 3 equals, and then my slope, x minus, and then my x1 is 5. Now we're going to distribute y minus 3, 2/5 x, and then 2 times 5 is 10. 10 divided by 5 is 2. And then add 3. A little prettier on this one. All right, so y is equal to 2/5 x plus 1. All right, I want you to try that next one on your own. So pause it, try it. Parallel first, then perpendicular. Remember to get it into slope intercept first, and then push play and check when you're ready. All right, so let's talk through this one. Subtract 2x, divide everything by 5. Slope should be negative 2/5. And so we're going to use that slope for our parallel equation. We're going to use the point for our x1 is 10 and our y1 is negative 3. Make sure when you do this, it's a minus and negative, so it turns into a positive there. Then we distribute, and then we subtract 3, and then we get our parallel line. So for perpendicular, we're going to flip that slope and change it to positive and use that same ordered pair there, 10 and negative 3, distribute. I don't really have my lines in there, but, and then subtract 3 to get our perpendicular line equation.